Good day, everybody. We are going to do another proof by induction divisibility question. So let's start. The first step, as I said, was that you have to take n to be any positive integer. Why does it have to be positive? Because it's given to us in the question that our n should be an element of the positive integers. So let's take our n to be 1, and if n is 1, the equation becomes 7 to the power of 1 minus 3 to the power of 1 minus 4 to the power of 1. That gives us 0, which is of course divisible by 12. That is the first step done. The second step is that we have to assume that the proposition, which is this thing over here, the proposition works for n equals k. So assume P of n is divisible by 12, where n is equal to k, and after writing this sentence, you always have to write down the equation by substituting n as k. So I'm going to write 7 to the power of k minus 3 to the power of k minus 4 to the power of k, and that we say is divisible by 12. Now, in the third step, what we're going to do is that we have to prove that P of n is also divisible by k plus 1. So we have already assumed that it works until k, but we have to now prove that it also works for the next number, which is k plus 1. So we are going to substitute k plus 1 in n. So the equation becomes 7 to the power of k plus 1 minus 3 to the power of k plus 1 minus 4 to the power of k plus 1. We can expand this equation and we will have 7 to the power of k multiplied by 7 minus 3 to the power of k multiplied by 3 minus 4 to the power of k multiplied by 4. Now, one important trick here, a really good trick, is that the assumption we have taken, we can rearrange it and then we can solve for 7 to the power of k. And whenever we solve it for 7 to the power of k, we can substitute that back in this equation right here. So I am here going to rearrange. From our assumption, we know that 7 to the power of k minus 3 to the power of k minus 4 to the power of k is divisible by 12. What it mainly means is that if I divide this equation by 12, I should get a positive integer. So here, m is any element of the positive integer. And now that we've had it, we can rearrange this equation and write 7 to the power of k minus 3k minus 4k is equal to 12 times m, and 7 to the power of k is then equal to 12m plus 3k plus 4 to the power of k. And now that we've got it, we can substitute that back in this equation. So I'm just going to copy it right now. Okay, so I'm going to substitute that back in the equation. So I have 12m plus 3 to the power of k plus 4 to the power of k, that is k. This will be multiplied by 7 minus 3 to the power of k times 3 minus 4 to the power of k times 4. I'm going to expand, so I'll just write 7 times 12m plus 7 times 3 to the power of k plus 7 times 4 to the power of k minus 3 to the power of k times 3 minus 4 to the power of k times 4. I'm going to rearrange this equation so that I have all the 3 to the power of k on one side and all the 4 to the power of k on one side. So I have 7 times 3 to the power of k minus 3 to the power of k times 3 plus 7 times 4 to the power of k minus 4 to the power of k times 4. Now, if you notice, I have 3 to the power of k, which is being multiplied by another number, and then I have again 3 to the power of k, which is again being multiplied by another number. So I can take 3 to the power of k as a common factor. So 7 times 12m plus 3 to the power of k multiplied by 7 minus 3. I can take similarly 4 to the k as a common factor. 4 to the power of k multiplied by 7 minus 4. And solving that gives me 7 times 12m plus 3 to the power of k times 4 plus 4 to the power of k times 3. Now, we know that this equation right here, that is being multiplied by 12. So this is divisible by 12. This is being multiplied by 3 to the power of k, or also by 4. We know that 3 and 4, they are factors of 12. So we know that this is also divisible by 12. And similarly, this is also divisible by 12 due to the same reason as I said before, because 4 is a factor of 12. And 4 to the power of k will also be a factor of 12. And anything multiplied by 4 to the power of k is divisible by 12. So that was it for the divisibility question. And as you can see, it is fairly simple. The main thing you have to note is that from our assumption, we always can rearrange the equation and then substitute that back in our third step. And that is how we solve proof by induction. Thanks for watching, and I wish you all a very productive day ahead.